This is Craig Ritu for the Hardware Academy, and in this course, we're going to go through an entire product design. We're going to start with a proof of concept, but before we build anything, we've got to go through a brainstorm and research phase. So I'm going to detail out what I go through in order to start thinking about a proof of concept design. I usually start out with a blank document and just start jotting down some of the requirements for this product. And I've given this some thought already, and I've decided that I want to design a cube. And this cube is going to do a couple things. It has a couple features. So this cube will have LEDs, and it's going to be battery powered, able to be recharged. And so depending on the orientation that you rotate the cube, the LEDs will do different things. So that's kind of the overview of what this product is going to be. So I typically just jot those down as requirements. So if I get into the requirements here, and I'll just kind of summarize what I just said. So this cube is, well, it's going to be a cube. So cube shape, and I have not determined, what the cube is going to be made from. This is really going through the electronics phase first, but I'll write that down as a requirement to understand the shape of this product. So it'll be cube shape. It's going to be portable. It's going to be rechargeable. It's going to have a way of powering it on and off, power on and off. It will have color LEDs, and it will be able to detect orientation. So with that list of requirements, you can start understanding maybe what components that we will be requiring for making this work. So let's think through some components here. So obviously when it's portable and rechargeable, we're talking about batteries. So I'm going to say we're going to need a battery. We'll probably use a lithium polymer battery. Those are pretty ubiquitous. Get them all shapes and sizes and charge densities and things. So it's a good selection there. So it's going to need to be rechargeable by the user. So they're going to need a way to recharge it. And typically that would be like a USB connector. So we'll do a user-facing USB connector. Not sure which one yet, but we can look that up. Whether it's a micro or USB-C, we'll determine that later. And then, of course, it's going to need a battery charging IC to manage that charge for the LiPo battery, because those have to be charged in a very particular way. So there's a lot of battery charging ICs out there that will help simplify that system. And then LEDs, of course, LEDs, but I think we're going to do addressable LEDs or addressable RGB LEDs that will allow us to do some cool things and control them. And in order to control those, we're going to need a microcontroller. And that's pretty typical in these kind of designs. And then to detect orientation, we'll probably do an accelerometer. That's pretty typical for orientation stuff. And then there's some components that we'll need in order to manage all this. So a voltage regulator is going to be used. And we also talked about the power switch. So we're going to do a switch for on and off. And whether that's a slide switch or some kind of tactile switch, we'll determine that in the design, where this is just kind of an overall list of components that we think we need. And the final piece here is going to be a way to program the microcontroller when it's in system on the board. And I don't want to program it through the USB connector, because this is meant to be a product and not really a development board. and I only want to use that USB connector for charging. So we're going to need a different way to interface with the microcontroller and program it. So I'll just jot down a programming port. I typically use a certain one, and I'll probably use that in this design, and I'll detail that later. So then I take this list and I start developing a block diagram to kind of see how all the pieces fit together, what connects to what, and I'll start getting some more details like how many GPIO I might need, voltage levels, and so I'll start researching actual components and figure out what I need based on that block diagram. So now I have my list of components. I'm going to take that list and we're going to jump over here to make a block diagram. And so I could just start reading through this list and kind of cross off the items as I detail them out. And I usually like to start from how this thing's going to be powered. So I will start with the battery. Just gonna put a battery block here. Battery. And so that battery is probably just going to be directly connected to the PCB, like soldered onto there, just with some wires. Or you could do a connector. Either way, that doesn't have to be determined right now. And so we have the battery. Cross that off there. And let's go to the battery charging IC. Let's make a block for that. Let's do it like this. Let's make this a different color. Battery charging IC. So battery charging IC. So obviously that's going to connect to the battery. I'll do a little connector here with an arrow. So that's going to charge the battery there. And then from the battery, we'll go to the power switch. So let's cross this off the list. So we're going to do some kind of switch between the battery. This. So we'll call this a switch. Make it a different color. Not that color. And that's going to deliver power to our system. So let's cross this off. And then, so this will probably go to our voltage regulator. Voltage regulator from the switch. Connect that there. Connect this here. Make this a different color. Let's make it red for voltage. And the battery charging IC, I believe, will probably connect to the regulator as well. Determine if that's accurate or not, depending on the battery charging IC. And let's cross that off. And then the USB connector, that is going to connect and deliver the USB 5 volts to this battery charger. So USB connector, that one's going to be orange. So let's connect this and this. Let's make this a little smaller. Okay, so USB connector is going to connect to the battery charger, which is going to charge the battery. Battery goes through the switch, which then is connected to the voltage regulator, which is going to provide the power to the system. So our main component is going to be the microcontroller. First, let's cross this guy off. So this is going to be the microcontroller. Let's make him big because he's important. And let's make this color. So this is going to connect. So the voltage regulator is going to deliver power to our system here. Let's make this a elbow connector. Connects there. This connects here. And we probably also want to connect the microcontroller to the battery charging IC. So maybe we can use our LEDs to display when the battery is charging or when it's charged. So it's always good to do. So you have access to those particular status lines of the battery charging IC. So I like to connect those together. And then, so we did the microcontroller. So the LEDs, don't know how many we're going to do quite yet. Let's just put a placeholder. So that'd be addressable RGB, stands for red, green, blue LEDs. It's probably going to be more than one. Probably be 4. Just the way that the circuit board might work in there. We'll just have to determine that when we get there. But we can put a placeholder here, and that's going to be connected directly to the microcontroller. And let's put it over here because it's also going to need to be powered by the voltage regulator for the system. So let's put another connector here. That's going to talk to this. And this regulator is also going to power these LEDs. And then we need this accelerometer. So let's cross this off. And then the accelerometer without the bullet. Let's put this centered. Change color. Accelerometer, that's going to talk directly to the microcontroller. And that's also going to be powered by the voltage regulator, so we can show a little connector from the regulator to the accelerometer. So the voltage regulator let's do a connector like this. This is going to go to the accelerometer as well. So we did the accelerometer, and now finally the programming port, which is going to be connected to the microcontroller. Programming port. And we'll connect that up to show that it goes to the microcontroller. Let's change the color. Use a connector. So that's a quick and dirty block diagram for our entire system. Cross all these items off now. And you can quickly see how many things are connected to the microcontroller. And depending what we get or we find for the battery charging IC and how many LEDs we do, and the accelerometer, we can see how many GPIOs we're talking about. So let's assume that from the battery charger, we're going to get a status for when it's charging and when it's done charging, so at least 2 lines there. And then from the accelerometer, there are different interfaces you can get, SPI interface, I2C interface, and then also straight analog out. So with an accelerometer, you have X, Y, and Z. So you might have 3 lines for that. And then for like I2C, you'll have 2 lines. So let's target an I2C accelerometer, because that's a pretty common interface, and it's only 2 wires. So let's say there's 2 for that accelerometer. Maybe there's some other controls there. So that's at least 2 for the battery charger, 2 for the accelerometer. Let's say we're going to do 4 addressable LEDs. So, the way the circuit board's going to sit in there, how I have it in my mind is it's just going to be on one plane, so we can illuminate 4 of the sides cleanly and uniformly. So let's just target 4 LEDs, and there are different addressable LEDs you can get. The one I've used in the past has a single data line. So and they daisy chain together. So really, these addressable LEDs only need power and ground and a single line from the microcontroller. So really, there's not many GPIO that we need. It's always a good idea to get more than you actually need in case you want to add some features later, or hook up things that you didn't think before. But generally, it seems like we're going to need 2, 4, 5 GPIO for this particular product. And then the programming port has a dedicated pins. We'll determine what those are going to be, and of course the power and ground. So that's what we're working with here. So with this system, I can go off and start looking to see what's out there, what's available. You know, it is 2021, where a lot of stuff isn't available, but we'll find what's available. And then we can also look at development boards to get up and running pretty quickly without doing a custom design just yet. So for the proof of concept, I'm going to go out and find some development boards for most of these things to accomplish what our system design shows.